Here we have this compound statement right here, and what we're going to do is we're going to use De Morgan's laws to negate this statement. Don't forget, a negated statement is where the truth values of one compound statement are the negations of the truth values of another compound statement. And De Morgan's law says that if you have a compound statement such as a conjunction P and Q, then its negation is a disjunction, not P or not Q. And if you have a disjunction P or Q, then its negation would be a conjunction, not P and not Q. So the first thing we're going to do is we're going to pinpoint where the simple statements are in here. You can see I forgot to set my alarm clock, or my alarm didn't go off. So it seems as though we have P or Q. So for P or Q, its negation is going to be not P and not Q. So the negation of I forgot to set my alarm clock or my alarm didn't go off, I can say I did not forget to set my alarm clock. And my alarm did go off. Now, some students may interpret this as I forgot to set my alarm clock or my alarm didn't go off, so they might think of this as a not Q, because it has a do not or did not. But it would be the same idea if we had P or not Q, which is what this can be interpreted as. Then we can write this as not P and Q. And that would be I did not forget to set my alarm clock and my alarm did go off. So you wind up stating the same statement. So to show what this looks like or why this works using a truth table, I'm just going to go ahead and I'm going to put in our standard statements here, P and Q. And hopefully by now you know exactly how to fill this out. And you can see I'm going to need some not P's and not Q's, so I'm just going to go ahead and put those in. I like to do that right away. So now I'll put in the truth table for P or Q. And then I'll build the truth table for not P and not Q. So for P or Q, the only time this is false is when the simple statements are both false. And here they occur right down here. So here it's false, Other than that, it's going to be true. And for this compound statement, this is a conjunction. The only time this is true is when both of these are true. And here they are right down here. Other than that, it's going to be false. So as you can see, the truth values for P or Q are the negations of the truth values for not P and not Q. So these two negate each other. I'll just write it in here, negate. The same will appear for when we do it for these two statements here. Winds up coming out to be the same compound statement as we read it out. So let's build the truth table for P or not Q. And then we'll do the truth table for not P and Q. Again, the only time that this is going to be false is if both of these are false. So P is false here, and not Q is false here. So it's false right here. Other than that, it's going to be true. This is a conjunction. This has to be true, and this has to be true for the entire thing to be true. So it's true right here. Not P is true right here, and Q is true right here. Other than that, it's false. And as you can see, they're negations of each other. True, true, false, true, false, false, true, false. So they negate each other again. So whether you interpret this as P or Q, or if you interpret it as P or not Q, if you make the adjustment in the negation, everything is still going to work out. And there you go.